Today we are doing the topic 3 review. Is the relation in the table below a function? Explain. Take a second to copy down the question and the table. In order for a relation to be a function means the x value cannot repeat. So I just have to look to see that my x value does not repeat. I have 1 for my x, 1 for my y. That's okay. I have a 3 here. I notice I have another 3 here. So this is not a function because 3 has 2 different y values. So remember, in order for any relation to be a function, the x value cannot repeat. Which of the following linear functions has the greatest initial value? Which has the greatest rate of change? So we have a table, we have an equation, and we have a graph. We're going to compare the initial value and the rate of change for all 3 of them. So take a second to copy down the question, the table, the equation, and the graph. I'm going to start by comparing the initial values. The initial value is just another way to say the y-intercept. That's the same thing. So when I look at my table, the y-intercept of a table is when my x is 0, what my y is. So this here, my initial value for my table is 0. When I look at my equation is in the form y equals mx plus b. My b value is my y-intercept. That's my initial value. So in this case, my b value is -1. So I have my initial value for my table of 0. My initial value for my equation is -1. Now I'm going to look at my graph. My initial value is the y-intercept, where it touches my y-axis. That is right here at 2. So my initial value for my graph is equal to 2. So when I compare these, the largest or the greatest is my graph. So I can just write that the graph has the greatest initial value. Now I'm going to see which one has my greatest rate of change. The rate of change just means the slope. To find the slope for a table, I need to see how the x is changing and how the y is changing. My x is going by +2. My y is going by +5. So my rate of change is how the y changes over how the x changes. So it's 5/2. And when I simplify that, it becomes 2.5. So my rate of change for my table is 2.5. Now my rate of change for my equation is just my bm value. So my m here is equal to 3. Now I'm going to determine my rate of change for my graph. I can pick 2 points. I can still use my y-intercept, and I can use this second point here at 3, 3. I'm going to see how it rises over the run. So it rises up 1 and it goes to the right 1, 2, 3. So here, my rate of change is 1 over 3. And this question asks which one has the greatest. So I can just write that the equation has the greatest rate of change. A line passes through the points 2, 4, and 6, 16. Write the equation of the line in slope-intercept form. Take a second to copy down the question. Slope-intercept form is always going to be y equals mx plus b. When I'm given 2 points, I'm going to start by finding my m. My slope formula is y2 minus y1 over x2 minus x1. I'm going to label my points as x1 and y1. So my 2 is x1, my 4 is y1. My 6 is x2, 16 is y2. If you reverse them, that would be okay, as long as it stays x1 and y1 together, and x2 and y2 together. And I'm always going to use parentheses to substitute into my slope equation. y2 is 16 minus my y1 value, which is 4. x2 is 6 minus my x1 value, which is 2. 16 minus 4 is 12. 6 minus 2 is 4. 12 divided by 4 is 3. So my slope is equal to 3. I can substitute that into my equation. So I know I have y equals 3x plus b. Now I also have to find a number for b. I could pick either point. I'm going to pick the first one because those numbers are smaller. 4 is my y. So I took my 4, which was my y value up top here, and I substituted it in for my y value here. I have 3, because that's still my slope, and now my x value is 2. So I'm going to substitute in 2 and bring down my plus b. I could have used my other points, it's just that the numbers would have been bigger. 4 equals 3 times 2 is 6 plus b. Subtract 6 from each side. 4 minus 6 is negative 2. So negative 2 equals b. Now that I have my slope and my y-intercept, I can write my final equation. Y equals 3x minus 2. Since my y-intercept is negative, I don't have to put plus a negative 2. I just leave it as minus 2. Kate traveled home and made several stops and detours along the way, as shown in the graph. State the intervals where the graph is increasing, decreasing, and remaining constant. Take a second to copy down the question and a quick sketch of the graph, and be sure to label these points, these intervals A, B, C, D, E, and F. We are going to list out all the intervals where my graph is increasing, where my graph is decreasing, and where my graph is remaining constant. I'm just going to go piece by piece and put them into the correct category. The first piece is A. My graph is going down from left to right, so that means that it is decreasing. That means that her distance from home was decreasing, so she was getting closer to her house. B, her distance is staying constant, so that means she stopped somewhere and didn't move. It's staying level. So that would be where her staying constant. For interval C, we are increasing or going up from left to right, so her distance from home is increasing. So that means she must have been walking farther away from home. Once she got to this point, her graph leveled off here. She stayed constant again, so she wasn't moving. At point E, or interval E, she's going farther away from home because her graph is going up from left to right, so her interval is increasing as well. And then at point interval F, it is decreasing from left to right, and it is going all the way down so that her distance from 0 is home, so she is back home. So at that interval F, her distance is decreasing. And the last question. Mr. Harris attaches a small tank of propane to his grill. He turns the grill on, so that should say on, and cooks. He then turns the grill off. After some time, he cooks more food. Sketch a graph of the relationship between the amount of propane in the tank and time. Take a second to copy down the question and the graph as well. For this problem, the amount of propane does not start at 0 because we know that he puts the propane to the grill and then he starts cooking. So I can start my graph anywhere. I'm just going to start it right here. Again, since these graphs do not have numbers, the amount of where we're starting at does not matter. So if he starts up here and he turns it on and cooks, over time the amount of propane he uses is going to decrease. Since they don't tell me how long he cooks or how much propane he uses, the intervals don't matter. I just have to get the idea that the amount of propane is decreasing. He then turns the grill off. After some time, he cooks more food. So at that point, it's staying constant. He's not using any propane, but he isn't gaining any propane either, so it remains constant. He then cooks some more food. Again, we don't know for how long, we don't know how much propane he uses, so I just have to show that my graph goes down. Your graph can stop right here. It doesn't say that he stops cooking, so we're not going to include a constant part here. If we have our graph go all the way down to the bottom, that's okay, but we don't have to because it doesn't tell us that he uses all of the propane. So since there's no numbers, we just have to show that the graph is decreasing, then remaining constant, and then decreasing again.